Alright. So we have seen normal function definition. That is one we used to write it with keyword def. We'll write a function name, arguments, the entire definition, right? And we will provide a function call to it, right? Now let's say if I'm writing a print val function and if I'm giving it a call, so once Python encounters the statements, it will search for the function definition, it will go up and it will execute the entire definition. And then after that only it will pass the control back, right? Now this approach will have some shortcoming if you are dealing with a large number. Let's say if you're generating 1,000 random numbers or 1,000 prime numbers at a time. So in that case, the user can see that program is stuck and it's calculating something and then it's returning a result, right? What if you want a numbers on demand? Because anyway, you will not work on such large values at a single time. Okay? If you want values on demand, if you want a state of a function to be retained, in that case, I can go with my generator. Okay? So generators will return me one element at a time and I can work on them. Okay. Now, let's take the same example of squaring the list. I have something like this. I'm passing it. I'm accepting this. If it's a normal way, I'll just see something like this, and either I can use my lambda, which can give me the entire values at a time, or I can use my for loop. Anything is possible. Value value. So if I want the square of all numbers, I have to write a definition, something like this, and I have to return all three girls, then only I can get all the results, right?
You are returning square. What is that?
Okay, I'm getting something like this. So this is giving me the entire list, right? Now how I can get element one by one. Let's say I want a square of 100 first, then a 200, the square of 20, then 30, 40. Okay, and it should be continuous. So it's not that if I get in 10, again 10 only, then 20, something like that. Okay. So that I can do with my generators. So for generators, you have to just replace your return statements with your yield statements. So if I just write the yield statement in my normal function definition, my Python will make it as a generator. So each value which I'm getting here, I'm yielding it. Okay. Now if I print the result, it will give me a generator object, which is again an iterable. Okay. Now how to get a value out of it? I'm getting a single value. The way it works is whenever you specify a next function and pass a generator object to it, At that time, it will start execution from start of the function till the next yield statement. Okay, and my generator will maintain the current state also. Okay.
So once generator object created, here result, and we access based on index. But it's running delay filter using next. Suppose I want to access last element.
You can write it inside a for loop. Whichever numbers you want, the number of elements you want.
But again, for loop is complete interval again.
Uh-huh.
So it's not possible to access the.
So it's like I am limiting the execution of this function actually.
No, but anyway, once as soon as you call square square function, it will be executed for the complete list
No. So it will execute till next yield statement only. So when I say first next, okay, it will start. So this L I have given, it will take one value. Okay, it will evaluate this and it will return the result.
But where are we calling here square? We are in next we are not calling square, right?
So this is my generator object. Okay, so it will store the values. Okay, but it will not return me. So it's not a complete execution.
So here, as soon as square result is square elements, it will not call the square function.
So it's just a generator object for that. No. And it will only call when you say next. Okay, so you can write multiple yield statements. That is also possible. But the execution will be from one yield statement till next yield statement. Okay?
We can't come back again. We cannot come back.
Like.
Suppose after
so you calculated till 30, you want to come back. Now one more thing is it will throw. Okay, so how many generators we have generated? 40, right? Okay. I'm doing it again. Yeah. So once your list is over, if it's empty, it will throw the stop iteration exception. Okay. Now in your normal for loop, my Python handles this exception internally. Okay. That's why you do not have to worry about when you say for value in L, and even if your list ends, it automatically stops your for loop there, right? But in case of my generator, I have to handle this exception. Okay, using my try and except block. Okay. So all my next statements. So one way I'll be writing all this. So I'll writing one next statement and it will be inside my for loop, and that will be inside of my try catch block. So, let's say except. Arbitration. So this is my generators. That only I have. So there will be no. So instead of return, I'll having the yield. So if you write a yield statement, it will convert this particular function to generator. Okay. Now try one example. So Fibonacci series. Try to generate it till 20 using generator.
28
Until 20. Number is greater than 20 then. Okay. So this is the concept of my generators. Okay. Now we will see my iter tools library. So we have seen our range function, right? which we used with my for loops, that if I want to generate a particular series of numbers, right? Now I have a library called itertools, which is mainly used if I have to do efficient looping. So it provides more flexibility as compared to my range function. So I have a library for that. You have to just say import itertools. Let's check if it's working fine or not. You can just say help of itertools. We will cover some of the functions in this library. Yep. So you can go and check help of it. Okay. But if itself is working, which means it's imported successfully. Now we will see some of the functions like count. Then again we'll revise them. iSlice. What else do we have? Sample. Repeat. Allocations. So let's say you have multiple lists. I have to combine them and then iterate through them. Okay, this is something I've got. Now without itertools, how you will do? You will just say L dot extend L2, then again L dot extend L3, and ultimately I can get the entire combined list inside of my L1, right? This is one approach, okay? Or for the same, I can use my itertools dot chain function. Okay?
Chain.
Yeah. Sure. No, I'll just say for okay. So first list first, then the second list, then the third list. If you want a list of that, you can easily do this. I'll just say L2 is equals to, again this returns itertools object. So itertools dot chain alpha L2 health.
So, second for by mistake.
So if you want to just combine it, you will not need a for loop. But let's say you have a condition that you have to combine all the list. Let's say you're getting in a multiple list, you have to combine them and iterate through them. Just add this instead of the range function, and you can work on it.
Here one also just displaying the just list of all numbers.
Exactly.
Now earlier we used a for loop for same iterator to chain function. Now we are just using list without using the for loop.
So the difference is that was giving me one element at a time from that list, right? Now I'm getting the entire list at a time. That is the only difference. So in that case, if I just put a break statement here, right after one, I'll say after value one, if I put a break, I'll get a single value, right? So that is it's combining and it's iterating through, right? I'm just getting single value. Okay. Clear?
Yeah.
Now, what is the difference between zip and chain?
Zip will return doubles.
Exactly. So now if you want to iterate based on the index, having same indexes, okay. So earlier it was part of itertools, now it's inbuilt function. So okay, so it's not part of my itertools library. So if you want to iterate through all these three lists simultaneously, then you can use your zip function. Because now if you do zip, in this value I have three values, right? So I'm iterating with all from all the lists simultaneously. Okay. So if you want to simultaneous iteration, you can use your zip. If you want to combine all the lists and iterate through it, you can use your chain function. Yeah. All right. Now, next thing I have is count. Now this itertools.count function will generate me infinite series of numbers. Okay. So we have seen a range function for which we used to specify the start, end, or at least the end, right? So it was giving me the element from that particular tree. Now this count function will generate me infinite series of numbers. So if I just run this now, it will give me, so it will go into the infinite loop of execution. Okay. So that's the code you need to check. So this is my itertools.count. So what is it? So it will generate me infinite series. So you have to specifically mention that what is the condition at what I have to break it. So if I do not specify anything, it will start from 0 and it will give me elements.
Just increase.
Yeah. So till your condition satisfied. Okay. Now let's talk about, so if I have to start from a particular point. It will start from 10. Okay. If I have to specify the increment, okay. Important thing, I cannot specify the end for this count. Okay, so count will be infinite. So only thing you can specify is your start and your end. Oh, sorry, start and the increment. Okay. So in case if you have a situation that you know the start point, but you just have to iterate till particular value is without a particular value, and you do not know what is the upper limit from a for loop, then you can go with your itertools.count. Okay. Next is isolace. So remember slicing. Something like this I have. So if I just put L of 2,6, it will consider as a start side second index, search for the 6 index and the less than this 6, right? And is not included. Right? This is my slicing. Now what is my I slice? Now if you want to iterate over the list which you are getting through your slicing. Okay. In that case, you can use your I slice function. Okay. So Let's say in this list, I want to iterate till this 60 only. So just say for value and iterative dot islice. So islice take first argument as an iterable. Okay. And the second argument it takes the start, and third argument is end. If you do not specify, if you just specify the two arguments, the second argument will be considered as an end. Okay. My first is 0, 1, 2, 3, 4, right? Let's say 5 colon he's actually a power cut at his place. There's a power cut at his place, so he said he'll join that. That's interesting. I'll send you.